Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. In this lecture, we are solving problem 4.9 from Applied Thermodynamics by McConkey. So, problem is steam expand reversibly in a cylinder behind a piston from 6 bar dry saturated to a pressure of 0.65 bar, assuming that the cylinder is perfectly thermally insulated. Calculate the work done during the expansion per kilogram of steam and sketch the process on a TS diagram. First we write given data for the problem. So the working fluid is steam. Behind from 6 bar initial pressure is 6 bar. P1 is equal to 6 bar and initially the steam is dry saturated. Initially the steam is dry saturated. And after expansion pressure decreases and volume increases. So after expansion pressure is 0.65 bar. Pressure decreases from 6 bar to 0.65 bar. Assuming that the cylinder is perfectly thermally insulated. Here is assumption. Cylinder is perfectly thermally insulated. Perfectly thermally insulation means that there is no heat loss and gain from the cylinder. When there is no heat loss and gain from the cylinder, that process is called adiabatic process. Adiabatic process or isentropic process. Constant entropy process. So there will be no heat loss and gain Q will be 0 and entropy of process of point 1 and entropy of point 2 will be same. S1 is equal to S2 is equal to S. Required is calculate the work done during the process per kilogram of steam. Per kilogram of steam mean that point specific work. Kilojoule per kilogram. Sketch the process on a TS diagram. These are the required to find work and draw TS diagram. Now we start solution. In solution, first we draw TS diagram. So temperature in degree centigrade and entropy in kilojoule per kilogram per Kelvin. This is saturation curve. Initially steam is dry saturated and initial pressure is 7 bar. Initial pressure is 6 bar. So on TH diagram this is constant pressure line. This is constant pressure line. So first point will be on this line, but it is clear from the statement that initially the steam is dry saturated. So this is saturated liquid line. So point 1 will be here. This is saturated vapor line. This is saturated vapor line and this is saturated liquid line. This line is called saturated liquid line and this line is called this curve, saturation vapor curve. Saturation vapor curve. Initial steam is dry saturated, so point 1 will be here. Now this is P1 is equal to 6 bar and pressure decrease after expansion, and P2 this is constant pressure line for P2 is equal to 0.65 bar. So 0.1 will be here, and when an expansion pressure decreases, so and this is constant entropy line. It means that second point will be, this will be straight vertical line, so process is from point 1 to point 2 because an expansion pressure decreases from point 1 to point 2. It means that the point 2 will be in wet region, and point 1 is in dry saturated vapor line. So work done, we have to find first to draw TS diagram, and second to find work done. So work done is equal to U2 minus U1. So for this we will find U1 and U2. So from saturated steam table, at pressure P1 is equal to 6 bar, U1 is equal to Ug because the vapor is dry saturated. So U1 is equal to Ug is equal to 2568 kilojoule per kilogram. And for U2 is in wet region, so for U2 we will use formula UF is equal to U is equal to UF plus X Ug minus UF. So for this we find X. So for X first we find S2. So uh, S1 is equal to Sg because this is unsaturated vapor line. From saturated steam table at pressure is equal to 6 bar, S1 is equal to Sg is equal to 6.761 kilojoule per kilogram per Kelvin. As the process is isentropic, so S1 is equal to S2 is equal to 6.761 kilojoule per kilogram per Kelvin. Now we find X2 with the help of S2. So as S2 is equal to SF plus X2 Sg minus Sf. From this formula we find X2. So from saturated steam table, at pressure is equal to P2 is equal to 0.65 bar, Sf is equal to 1.169 kilojoule per kilogram per Kelvin, and Sg is equal to 7.504 kilojoule per kilogram per Kelvin. Now put these values in formula S2. So S2 is equal to, the value of S2 is, S1 is equal to X2, so S2 is equal to 6.761 kilojoule per kilogram per Kelvin is equal to SF. The value of SF is 1.169 kilojoule per kilogram per Kelvin plus X2. The value of Sg is 7.504 kilojoule per kilogram per Kelvin, and SF is 1.169 kilojoule per kilogram per Kelvin. Now 6.671 kilojoule per kilogram minus 1.169 kilojoule per kilogram per Kelvin is equal to X2, and 7.504 minus 1.169 is equal to 6.335 kilojoule per kilogram per Kelvin. Now difference of 6.761 and 1.169 is equal to 5.592 kilojoule per kilogram per Kelvin is equal to x2 into 6.335 kilojoule per kilogram per Kelvin. Now divide both sides by 6.335. So x2 is equal to 5.592 kilojoule per kilogram per Kelvin divided by 6.335 kilojoule per kilogram per Kelvin. So x2 is equal to 0.8827. After rounding, this will be equal to 0.883. And this kilojoule per kilogram per Kelvin will be cancelled with kilojoule per kilogram per Kelvin. Now we find U2. So U2 is equal to UF plus X UG minus UF. First we find UF and UG from saturated steam table. So from saturated steam table, at pressure is equal to 0.65 bar. UF is equal to 369 kilojoule per kilogram. And UG is equal to 2492 kilojoule per kilogram. Now U2 is equal to, putting values in this equation. Now U2 is equal to UF, the value of UF is 369 kilojoule per kilogram per Kelvin, plus X2, the value of X2 is 0.883, into UG minus UF 2492 kilojoule per kilogram minus 369 kilojoule per kilogram. Now U2 is equal to 369 kilojoule per kilogram per Kelvin plus 0.883, and 2492 minus 369 is equal to 2123 kilojoule per kilogram. Here no per Kelvin. So U2 is equal to 369 kilojoule per Kelvin plus multiply 0.883 by 2.2123. The answer will be 1874.609 kilojoule per kilogram. Now U2 is equal to 8369 with 1874.609. The answer will be 2243.609 kilojoule per kilogram. So now we can easily find work done. So work done is equal to U2 minus U1. The value of U2 is equal to 2243.609 kilojoule per kilogram minus the value of U1 is 2568 kilojoule per kilogram. So work done is equal to minus 324.39 kilojoule per kilogram. This is specific work done per kilogram. Now negative sign mean that work output or work done by the system or work of expansion is equal to 324.39 kilojoule per kilogram. So the problem is solved. And for more videos, please like and subscribe my YouTube channel and share with your friends. Thank you.